Good morning. Today's lesson is 1.5. Common factor. Our essential question today. How can you use the strategy draw a diagram to help you solve a problem involving the greatest common factor and the distributive property? Let's unlock the problem. A trophy case at Riverside Middle School holds 18 baseball trophies and 24 soccer trophies. All shelves hold the same number of trophies. Only one sport is represented on each shelf. What is the greatest number of trophies that can be on each shelf? How many shelves are there for each sport? Use the graphic organizer to help solve the problem. So what do I need to find out? Well, I need to find out the greatest number of trophies on each shelf for each sport. What information do I need to use? Well, I need to use the number of trophies for each sport. How will I use the information? I can find the greatest common factor of 18 and 24, and then I can use it to draw a diagram representing the shelves of the trophy case. So let's look over here. The total trophies of baseball and soccer. So there were 18 baseball and 24 soccer. So we need to find the greatest common factor of 18 and 24. The greatest common factor of 18 and 24 is 6. Now, it says to write each number as the product of the greatest common factor with another factor. So, for 18, 6 times 3 is 18. And 6 times 4 is 24. So that represents the 18, and that represents the 4. So if I'm using the distributive property, we say 6 times this 3, and 6 times the 4. So if I was using the product to draw a diagram in the trophy case, then the B's would represent baseballs and the S's would represent trophies. So remember so let's draw that in. So I have my 18 baseballs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And then for my soccer balls, I should have 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So looking at the diagram, you can see that there are 6 of each ball on the shelf, and that there are 3 shelves of baseballs and 4 shelves of soccer. So we are going to write that there are 6 trophies on each shelf, and there are 3 shelves of baseballs and 4 shelves of soccer trophies. Let's do one more problem before you work together. Delia is bagging 24 onion bagels and 16 plain bagels for her bakery customers. Each bag will hold only one type of bagel, and each bag will hold the same number of bagels. What is the greatest number of bagels she can put in each bag? And how many bags of each type of bagel will there be? We're going to use the graphic organizer to help us solve the problem. So first of all, what do I need to find out? Well, I need to find out the greatest number of bagels that Delia can put in each bag and the number of bags for each type of bagel. What information do I need to use? Well, I need to use the fact that there are 24 onion bagels and 16 plain bagels. How will I use this information? Well, I'll find the greatest common factor of 24 and 16, and then I'm going to use it to draw a diagram representing the bags and showing the contents. So let's solve the problem. First, I'm going to need the total bagels, which is onions plus plain. So that's 24 onions and 16 plain. Then I'm going to need to find the greatest common factor. A good way to do that is to simply do the list like we did before. So I listed out the factors of 24 and the factors of 16. They have a lot of things in common. They have 1, let me do my better highlighter. They have 1 in common, they have 2, they have 4, and they have 8. But the greatest being 8. So the greatest common factor of 24 and 16 is going to be 8. So now I'm going to write 24 and 16 as a product, right? So that means I'm pulling that 8 out using like the distributive property. And so 8 times 3 would get me the 24, and 8 times 2 would get me the 16. So then I'm going to use the product next to draw a diagram representing the bags. I'm going to use rectangles to represent the bags, and I'm going to use zeros to represent the onion bagels, and I'm going to use P to represent the plain bagels. So if I were to do that, here's my onions, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's my 24. And then I have my 16 plain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So now I'm going to put a box around for my bags. I'm going to have 1, 2, 3, 4, 5 bags. So I'm going to have 5 bags with 8 bagels in each. I'm going to have, so my 24 onions, and I have my 16 plain. So there's going to be 8 bagels in each bag, and there's going to be 3 bags of onion bagels, and there's going to be 2 bags of plain bagels. So let's explain our reasoning. It wants to know how the greatest common factor of 24 and 16 is 8 helped me to solve the problem. Well, it helped me because the greatest common factor represented the number of bagels that Delia could put in each bag. And once I knew that, I could find the number of bags that each type of bagel had. So I did the bagels first, and then I circled the bags. All right, the rest of the problems I'm going to have you do with a partner. I'll be available if you need me as well. And then I want you to do the online on Think Central. Good luck.